Thank you, Jasper, for explaining the code for our IoT system. Now, I'm Raymond Choy, and I'll cover the data transmission, which is the MQTT, cloud integration, InfluxDB, and visual aspects of our IoT system, visualization being the Grafana. My primary responsibility was to ensure that the sensor data collected by our microcontroller is transmitted efficiently and stored securely in the cloud. I also worked on setting up a real-time visualization dashboard using Grafana to make the data accessible and user-friendly. Let me walk you through the details. Our system uses the MQTT protocol for data transmission. The MQTT is a lightweight messaging protocol ideal for IoT applications because it is designed to be fast and reliable, even over low bandwidth networks. This is important for our system as it allows us to maintain real-time data flow from the ESP32 microcontroller to the cloud. The data packets are structured in a way that allows us to send both temperature and touch data in a compact format, reducing latency and making it easier to handle larger volumes of data. We can show this in real time. The MQTT Explorer touch sensor at 53 right now, it instantly jumped to 160. Thermistor, which measures the temperature, 26 right now, 28 just from my fingers. Now we'll explore this in InfluxDB. Once the data reaches the cloud, it's stored in InfluxDB, a powerful time series database. InfluxDB is particularly suited for our project because it is designed to handle larger volumes of timestamp data efficiently, which is exactly what we need for continuous environmental monitoring. To integrate InfluxDB with our IoT system, we configured our database with specific parameters that allow it to store and organize the temperature and touch data. This setup ensures that users can access both real-time and historical data seamlessly, making it easier to track trends and analyze patterns over time. As seen before, the temperature has changed from touched earlier, and the touched earlier in real time. Just that quick, from MQTT to InfluxDB, drawing that data across. Now, let's look at how we visualize the data. We set up a Grafana dashboard that pulls directly from InfluxDB, that pulls the data from InfluxDB and displays it in real time. The dashboard includes visualizations like line graphs for temperature changes and gauges for touch interactions, giving users an intuitive view of environmental conditions. You also configure alerts in Grafana, so if a sensor reading crosses a critical threshold, like a sudden temperature spike, an alert is triggered. This feature enhances safety by notifying users immediately, allowing them to take quick action. Here, I can explain the further code in the Grafana. The bucket line specifies the data source, which is the InfluxDB bucket named group ESP32. This bucket is essentially a database or storage container where the data is stored at. The time range filter filters the data based on a specific time range, where V time range start and V time range stop are variables representing the start and end times of the desired range. Only data within this time frame will be included in the query results. The measurement line further filters the data to include only records where the measurement is IoT sensors, which is seen in our code in the VSC. Measurements in InfluxDB act like tables in traditional databases, grouping related data points. Here it selects only the data from the IoT sensor's measurement. The field line applies a field filter, which means it only selects records where the field is either temperature or touch, just only those two. Fields in InfluxDB represent specific data types or metrics, so this filter limits the output to records containing temperature or touch values. Therefore, this query retrieves temperature and touch data from IoT sensors measurement within the specific time range in the group ESP32 bucket. In summary, our IoT system provides a cost-effective and a scalable solution for environmental monitoring. The benefits include real-time monitoring, remote data access, reduced operational costs, and enhanced safety through instant alerts. Our system can be applied in various industries, from smart buildings to environmental monitoring and industrial facilities. Overall, we believe this project highlights how IoT can transform data management and decision making, giving users a comprehensive view of their environments with meaningful infrastructure. To further add to that, based on what I explained earlier, we believe our IoT system is great at monitoring environmental conditions through Internet of Things communications of MQTT, IoT Cloud, which is InfluxDB, and a data representation, which we use Grafana. With low budget entry, there is little drawback to our system. Thank you for your attention, and I look forward to any questions you may have.